Hello viewers, welcome back to BakoMaths, and today's lesson we'll be looking at how to solve systems of linear equations using the Gaussian elimination procedure. And then this video focus on cases where we get no solution or inconsistent solution to the systems of linear equations. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we start with the systems of linear equations. So first, we have to augment matrices for the systems of linear equations. And so we can write here as the augmented matrix. And then that is of the form. So you know the coefficient of x in the first equation is 1. The coefficient of x in the second equation is 1. And then the third equation is also 1. We go to y, and the first equation is 2. In the second equation is 3. And the third equation, we can see there is no y, and so it goes to 0. Now for z, the first equation is 3. The second equation is 5. For the third equation is -1. And then for w, the first equation is 4. The second equation is 7. And then the third equation is -2. From here we bring our constant terms, and that is 5, 11, -6. Now the idea here is that we want to change or transform this augmented matrix to row echelon form, and that we have 1, 0, 0, we have 1, 0, 1, and then we may also get some other elements here, but that may not get, or that may not be our focus. But then our focus here is to change the augmented matrix to the element we see in the row echelon form as green. So that becomes our focus for today's video, and it's very simple. So we want to change this augmented matrix to this form, which means that this should be 1, and this place should be 0 followed by 0. This 3 should be 1, and then at this side should be 0, and we should get 1 here. And then other elements we may get aside may not get us bothered. And so we can rewrite our augmented matrix here, and we have 1, 2, 3, 4, 5, and then we have 1, 3, 5, 7, 11. So let's take it back. So we have 11 as well. So 11, and then it follows to 1, 0, -1, -2, -6. So the idea here is that we have to change this place to 1, and then it's already 1, and so we leave it like that. And the next step is for us to change the 1 in row 2 to 0, and we can do that by considering the pivot in row 1. And so since the effect is going to happen in row 2, we can basically write here as row 2 is equal to, how do we get the formula? We can get it by simply doing this illustration, and since we are considering row 1 and row 2, we can write here as row 1 and row 2. And row 1, the first element is 1, and row 2 is also 1. Now we ask ourselves, what must we do so that this element, when added, goes to 0? And so the idea here is that when I subtract from row 1 and add to row 2, I'm going to get 0. So that is -1 plus 1 is equal to 0. And now our formula now becomes minus row 1 plus row 2. So minus row 1 plus row 2. And so we continue for the rest of the other elements, and in row 1 we have 2. Remember, we are subtracting, we bring it, and row 2 we have 3. And so the addition now gives us -2 plus 3, and that gives an answer of 1. And then in row 1 we have 3, that is -3, and in row 2 we have 5. And so when we sum this, we are going to get -3 plus 5, that gives an answer of 2. And in row 1 we have 4, because there is minus, we bring it, and in row 2 we have 7. And so the addition now gives -4 plus 7, and answer is 3. And then in row 1 we have 5, so it becomes -5 here, and in row 2 we have 11. And so its addition now gives -5 plus 11, and so we get 6. and this becomes our new element for row 2. And so you can rewrite or write a new matrix as, so we have 1, 2, 3, 4, and 5. So it means that we are going to maintain the values for row 1 and row 3 since the effect did not happen at that side. And so row 2 now becomes 0, 1, 2, 3, 6. And then row 3 we have 1, 0, minus 1, minus 2, minus 6. Now the next step is for us to change the one we see in row 3 to 0, and we can do that by considering the pivot in row 1. And so we can also follow the same trend or the same procedure as we did for the first matrix in getting that row to be 0. And so we can simply write here. Now since the effect is going to happen in row 3, we can write row 3 is equal to, so to get the formula, we are taking into consideration row 1 and row 3. And we know the first element in row 1 is 1 and the first element in row 3 is 1. So we ask ourselves, what must we do so that this element when added goes to 0? Simply when we subtract from row 1 and add to row 3, then we are going to get 0. So minus 1 plus 1 is equal to 0. And it continues for the rest of the elements. And in row 1 we have 2. Since we are subtracting, we bring it. But before that, let's write our formula. So it becomes minus row 1 plus row 3. So we have here as minus row 1 plus row 3. And this becomes our formula. And then in row 1 we have 2, we bring our minus, and row 3 we have 0. And so the addition now gives minus 2 plus 0, that is minus 2. It continues, then we have minus 3. It's 3, but when you bring the minus, it becomes minus 3. And then at this side is minus 1. And so minus 3 minus 1 is minus 4. It continues to 4. We bring our minus, it becomes minus 4. And row 3 is minus 2. And so its addition now gives minus 4 minus 2. And we have an answer of minus 6. Now it continues and we have 5. So it becomes minus 5. And in row 3 we have minus 6. And so its addition now gives minus 11. But remember, meant for row 3, and a new matrix can be written as, and so we have, since the effect not happen in row 1 and row 2, we maintain the same values for them. And at this point we can write here as 1, 2, 3, 4, and we have 5. And then in row 2 you have 0, 1, 2, 3, 6. And in row 3 we now have 0 followed by minus 2, and we have minus 4, minus 6, and minus 11. Now the next step is for us to change this one. If it was not supposed to be 1, we'd have changed to 1, but it's already 1, so we leave it like that. And so we move on to the next one, and the next one we are thinking of making the minus 2 we see here to 0, and we can do that by considering the pivot in row 2. So we can change the minus 2 here to 0 by considering this one in row 2. And so since the effect is going to happen in row 3, then we can say row 3 is equal to, now how do we get the formula? We can do the same illustration like we did for our previous matrix, and with that we are going to consider row 2 and row 3 like we said earlier. And so simply we can write it as row 2 and row 3. And so we know the first element for row 2 and row 3, they are 0, so we can write it 0, 0, and the addition now gives us 0. That may not be our focus. Our focus is to change the minus 2 in row 3 to 0, and then it follows to the next element in row 2, that is 1, and in row 3 we have minus 2. So we ask ourselves, what must we do so that this element when added goes to 0? So simply if you multiply this side by 2 and we add, then we are going to get 0. So it means 2 times 1 is 2 and minus 2, so we get 0. And so we can now say 2 row 2 plus row 3 is now our formula. So we have 2 row 2 plus row 3. And that's very simple. Now we continue, and so the next element we have in row 2 is 2, and we write, and in row 3 we have minus 4. And so 2 times 2 is 4, minus 4 is equal to 0. Now we continue with the next element in row 2, that is 3. So 2 times 3, and then the next element in row 3 is minus 6. And so 2 times 3 is 6, minus 6, we get 0. And then we continue with the next element, we have 6. Now in row 3 we have minus 11. And so we get 2 times 6 is 12, minus 11, and we get an answer of 1. And this becomes a new row for row 3. And so we can now write our new matrix as, so we have here as 1, 2, 3, 4, and then we have 5, 0, 1, 2, 3, 6. And then our new element for row 3 now becomes 0, 0, 0, 0, 1. Now we have been able to change the matrix to row echelon form. Now realize that this place should have been 1, but we can see automatically by following the process of the addition, we realize that it has been changed to 0 automatically, and there is no way we can do something about it. We cannot change 0 to 1, and so maintain the answer like that. And so we can continue by back substitution, and so we can write here as by back substitution. Now how do you do back substitution? Remember, this row were coefficient of x, and then these were coefficient of y, coefficient of z, and coefficient of w. Remember, this happened to be our constant. And so how do we get it? So at this point, 1 times x gives us x, and we know 2 times y gives us plus 2y. It continues, and we know 3 times z gives us plus 3z, and we know 4 times w gives us plus 4w is equal to the constant, that is 5. And then we can continue. 0 times x gives us 0, and we can ignore that one, and we know 1 times y gives us y. 2 times z gives us 2z, and then 3 times w gives us 3w. Now it's equal to the constant 6. 0 times x. For the sake of a bit explanation, let's try and write something like 0x. Let's write it properly, and we have 0x plus, we know that 0 times y, we can write something like 0y, and then 0 times z plus 0z, and then plus 0 times w, you get 0w is equal to 1. Now let's look at something critically. So we have 3 equations, and these 3 equations, we can see that the coefficient of x, y, z, w, they are equal to 5, and then the same thing applies to the second equation. Now in the third equation, we can see that 0 plus 0 plus 0 plus 0 is equal to 1. So it means that 0 is equal to 1. That is what the third equation is trying to say. But we all know that 0 is never equal to 1. But we can clearly see that if we have 0 to be equal to 0, then that makes sense, because 0 is equal to 0. In the same way, if you have 1 to be equal to 1, it makes sense that 1 is equal to 1. But in this case, 0 is never equal to 1. And because of this statement in row 3, it is making this question have inconsistent number of solution, or inconsistent solution, or no solution, because there's no way 0 is equal to 1. And when we have a matrix of this form, a final matrix of this form, such that all the rows, they are equal to 0, and then the constant happens to be 1 or happen to be a counting number, then it means that we are going to get inconsistent number of solution. But assume if we had a number that this place, so let's assume this place was to be 1 or 2 or 3, we couldn't have said that this solution is inconsistent, because definitely we are going to get like w is equal to 1. That makes sense. But here is the case that we are getting all of them to be 0, and it's making the matrix or the systems of equations to have inconsistent number of solution, or no solution. And based on this statement, we can simply write or state that the system, so we can now write the system. So therefore the system has no solution, or it has inconsistent solution. And that is how we can solve the systems of linear equations using the Gaussian elimination procedure. And so this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity.